Hi chemistry students, welcome to a little reminder refresher course on dimensional analysis. So you may recall me talking about this either as dimensional analysis, or you may have heard me call it parenthetical conversion. What we're going to do is we're going to start out with our information. So you start out with, in this case, 1.79 pounds. We want to convert it to grams. The first thing you need to do is you need to determine what your conversion factors are. So you've got your conversion factors. Remember, these are the ratios that we build that we can just plug directly into our dimensional analysis. So what we're going to start out with is we're going to start out with pounds. We need pounds to go into metric. So we want to take our pounds and change them into kilograms because that's a conversion factor we actually have. So we know that 1 kilogram is equal to 2.2 pounds. Okay? So remember, we can write this two different ways. We can write it either as 1 kilogram over 2.2 lbs, or we could write it as 2.2 lbs over 1 kilogram. These aren't actual division. Remember, these are not actually dividing anything. They are just telling us that this is the ratio. You have 1 kilogram to 2.2 pounds, or you have 2.2 pounds to 1 kilogram. That's all it is. So the next thing we're going to do is we're going to take our known. So in this case, our known is what we're starting with, always. It's also known as a given. So let's take our known, which is our given, which is our 1.79 pounds, and let's put it here just so we can remember. When we get into the moles unit, this may be a little bit more confusing for you to figure out what exactly is your given. That's why we're going to practice writing it now, so that in the future, when you do these problems, it'll be much easier for you. So now we've got our known and our given. What we're going to do now is we're going to take this and we're going to start our conversion. So if we start with our known, so we've got our 1.79 lbs, okay? What we want to do is we want to draw big parentheses and put a bar in it, okay? And remember that your pounds is over 1, okay? You divide something by 1, nothing happens, right? So any number that you have, you can always remember that it's on the top, and the way it's on the top is you're always dividing by 1. So this first parentheses, what we want to do is we want to put in our first conversion factor. Now remember, if something's on the top, it is always, when something's on the top, it is canceled out by what we put on the bottom. So as of right now, our pounds are on the top, so we want pounds to be on the bottom here. So let's take the one of these that has pounds on the bottom, which would be 1 kilogram to 2.2 pounds. So let's just move that on down. So all you have to do is put it directly into your parentheses. So you've got 1 kilogram over 2.2 lbs. So our pounds cancel, but look, we're still left with kilograms. We still have to convert to grams. So what we're going to do now, we scoot this over a little bit. What we're going to do now is we are going to open another set of parentheses. Now, how do we convert grams or kilograms to grams? Well, we know that we have 1,000 grams per 1 kilogram, okay? Or we know that we have 1 kilogram per 1,000 grams, right? So remember, whatever goes on the bottom cancels out what's on the top. Now at this point we have kilograms on the top. So we're going to take kilograms and put it on the bottom. Now this one has kilograms on the bottom, so we're just going to take that and plug it directly in. So all you have to do is write 1,000 grams over 1 kilogram. Our kilograms cancel, and we are left with our grams. So now what you do is you multiply across the top and you multiply across the bottom. So now what we have is we have 1.79 lbs or I'm sorry, at this point the units have disappeared for that. So 1.79 times 1 times 1,000, and that 1,000 still has its grams because the grams did not cancel. And we're going to divide that by 2.2 times 1. And this actually, in theory, this little 1 would be times it as well. So now we just do the math and get our answer. Just multiply the top, multiply the bottom, divide, and we're done. So now what we're going to do is we're going to erase all this, and we're going to do another problem, this time with density. So let's get started. So the important thing to remember with density is that density is just mass divided by volume. So remember, density is mass over volume, okay? So the way that we usually write this is we usually write this as, say, the density of lead, which is abbreviated PB, is 11.3 grams per cubic centimeter, okay? All a cubic centimeter is a measure of volume. You've got a cube. We're saying if you had 1 cube of lead, this is how much it would weigh, okay? So when we have this in a problem, we might see an example such as you have a 32 centimeter cubed block of lead. And what we want to know is how many grams, okay? So when we write our density, it's important to remember that we can write our density as a fraction. It is 11.3 grams over 1 centimeter cubed. When we're writing it like this, we usually just don't bother to put that 1 in there, because when you divide by 1, what happens? Absolutely nothing. So what we need to do is we need to take this and convert it to this so that we can use it in our dimensional analysis. So now we know that we have our 32 grams per centimeter cubed. That, or 32 centimeters cubed, my apologies. That is going to be our known this time. So we take our known, or our given, and we put it on our left. So we've got 32 centimeters cubed, okay? So now what's important to remember with density is that it's just a ratio, like our 1,000 meters to 1 kilometer, or 60 seconds to 1 minute. It's the same thing. All it's saying is that you have 11.3 grams per 1 centimeter cubed. So we could actually write this as 1 centimeter cubed per 11.3 grams. So now remember, we're going to need to convert this by having whatever's on the top go onto the bottom here, okay? When we set this up, it's the same thing as saying 32 centimeters cubed over 1. So our centimeters cubed are going to be on the top, which means they now need to go on the bottom. Of these two ratios, the first one has centimeters cubed already on the bottom. So all we have to do is plug it in directly. So we have 11.3 grams over 1 centimeter cubed. So all you have to do is cancel out your centimeters cubed, hit equals, you put times across the top, times across the bottom, so you have 32 times 11.3 grams, and that's divided by 1 times 1. All you have to do is do the math, and you're good to go. It's as simple as that. So let me know if you have any questions. Feel free to email me or to contact me on ManageBack, and hopefully you will do well on the test.